Okay, so welcome back. This is the second video of the two problems that I'm going to do. This problem is on null hypothesis testing for population means. The last one was proportion, so this one will be population. So the problem here is buckets of paint coming off the production line at the ABC paint factory are labeled as containing 1 gallon. If the buckets typically contain a different amount, then the filling machine should be recalibrated. Here are the volumes in gallons from each of 10 buckets sampled off the production line. You can see the values listed there. Does this data provide evidence at the 10% significance level that the machine needs recalibration? So the first thing that we do, and it's a lot like the steps we use for finding a proportion, is you have to identify the population parameters being tested. So in this case, it would be how much a bucket coming off production line at ABC factory, how much a bucket coming off the production line at ABC factory are labeled as containing. So it wants to know if the machine should be recalibrated, so you want to know how much it contains. So the second step is again like the step for the proportion. It is to state the null hypothesis. And it's the same symbol as used in the proportion problem. It's this H of O, or H of 0. And for this, it's labeled as containing 1 gallon. So that will be our null hypothesis. HO equals 1. Now step 3 is again like the proportion example, state the alternative hypothesis. And just like in the last step, this will be labeled as HA. As HA. So what we want here is we have to go back to the problem and read it again. So it says if the buckets typically contain a different amount. So the alternative hypothesis will be a different amount or not equal to 1. Because if it's different amount, then it throws everything off. So our HA does not equal 1. And if I was to write this actually out on a sheet of paper, it would look like an equal sign with vertical. It would look like an equal sign with a line drawn through it. So step 4 is again the same as the hypothesis testing for proportion, and that is to select the significance level. And like in the proportion example, it will typically give you this. So here it's at the 10% significance level. So we can put this as A equals 0.1 for 10%. Now here's where it gets a little bit different. Step 5 is the same. It's to identify the test statistic. Well, the test statistic you're using is different. So in the proportion example, we used the Z test statistic. Here we will use the T test statistic, which equals this, as you can see here. Let's copy and paste that. Oops. Sorry about that, just a little difficulty. Let's try that again. Okay, much better. So T equals X minus mu of O, or the mean of the hypothesized, or the hypothesized mean, so X bar minus the hypothesized mean, divided by S over the square root of N. And S typically here will just be your standard deviation. So now we go to step 6, which is to check the necessary conditions for test statistic. And it's the same parameters for the most part. Here, the sample mean X must be approximately normally distributed. And if N is greater than or equal to 30, then what's known as the central limit theorem applies. You should have learned about that previously in the statistics course. And if N is less than 30, then check your sample with a histogram, which you should have learned about at the beginning of the course as well. So if there are skews and outliers, stop, because the interval will not be accurate. So in this case, N, if we go back to the problem, was 10. So that 10 is less than 30, so we have to check it with the histogram. So to do that, you go to your calculator. I have a TI-84. So you go to Stat, you hit the Stat button, and then you should see where it says Edit, and it should be highlighted number 1 that says Edit. You click on that, and then it should take you to a list where you have to name your list. So it won't allow you to do the word buckets, so I just call this one Buck, B-U-C-K, and enter your values. So enter each value. So enter. I'm about to stop because I'm running out of time. So we'll see you in the next video.